Tonight, we are going to talk about something both mysterious and profoundly simple: the speed of light. Light is all around us. It fills our skies every morning. It paints the stars across the night, and in the silent reaches of space, light is the messenger that carries stories from distant galaxies all the way to us. The speed of light is not only fast, it is the fastest. It is the ultimate speed limit written into the very fabric of reality. Welcome and good evening. Take a moment to settle in. You may be lying down, preparing to drift into sleep, or perhaps you're simply looking for a quiet, calming journey through the cosmos. Don't worry about remembering every detail. You don't need to concentrate. Just allow the words to wash over you like ripples in calm water. And as we journey together, slowly, gently, we will explore what that really means. We will ask, what is light? How fast does it travel? But there's something extraordinary about light. It does not just shine, it races. It moves with a speed that is unlike anything else in the universe. Light is the messenger that carries stories from distant galaxies all the way to us. So now, let's begin. Let's step softly into the cosmic story of the speed of light. As you listen, feel free to let your eyes grow heavy, let your breathing slow, and if you drift off, that's perfectly fine. The story of light will continue even if your mind floats away into dreams. Light is more than just brightness. It is more than what we see with our eyes. At its heart, light is a form of energy. Scientists describe it as an electromagnetic wave, a gentle ripple that moves through space. Imagine dropping a pebble into a pond. The ripples spread outward, carrying energy across the water. Light works in a similar way. Though the pond is invisible, it is the fabric of electric and magnetic fields. Light is also made of tiny particles called photons. These are the smallest packets of light energy, indivisible little messengers. Sometimes we describe light as a wave, sometimes as particles, and both are true. This dual nature makes light strange and beautiful. It behaves like ripples, but also like countless tiny sparks. Not faster, not slower, but always precisely the same. Scientists have measured this speed with astonishing precision. It is exactly 299,792,458 meters per second. That's nearly 300 million meters every second. In more familiar terms, light races at about 186,000 miles per second. In a single heartbeat, light can circle the Earth 7.5 times. Try to imagine that. You blink, and light has already traveled from here to the moon. For us, this speed feels infinite, but it is not. It is vast but measurable, and it sets a hard limit on how quickly information, energy, and matter can move. The speed of light is more than just a number. It is woven into the equations that describe the universe. It is the C in Einstein's famous formula, E equals mc squared. It defines how time and space adjust themselves, so that light's speed remains constant for everyone, everywhere. And this constancy is the key to relativity, and to understanding why the speed of light is the ultimate cosmic speed limit. But before we explore those ideas, let's drift back in time to the centuries when humanity first began to wonder, is light truly instant, or does it take time to travel? For much of human history, people believed light traveled instantly. After all, when lightning flashes, we see it almost immediately. When you look across a field, you don't notice any delay. But clever observers began to ask, could light actually take time to move? Could it have a speed? The first major clue came in the 1600s from a Danish astronomer named Ole Romer. Romer was studying the motions of Io, one of Jupiter's moons. Io passes into Jupiter's shadow on a regular schedule, creating tiny eclipses. But Romer noticed something odd. Sometimes the eclipses appeared later than expected, and sometimes earlier. He realized the difference came from Earth's changing distance from Jupiter as Earth orbited the Sun. When Earth was farther away, light from Io took longer to arrive. From this, Romer estimated that light did not move instantly, but instead took time to cross space. He was the first to put numbers on its speed. Others followed. In the 1800s, French physicist Hippolyte Fizeau devised a clever experiment using a rapidly spinning toothed wheel. A beam of light passed through a gap in the wheel, traveled to a mirror some distance away, and returned. If the wheel spun fast enough, the returning beam would be blocked by the next tooth. By adjusting the speed of the wheel, Fizeau could measure how long the light took to make the round trip. Not long after, another French physicist, Léon Foucault, improved the method using rotating mirrors. His experiment measured the speed of light even more accurately. And then the American physicist Albert Michelson devoted much of his career to perfecting these measurements. Using long paths of light and exquisitely precise equipment, he achieved extraordinary accuracy. Michelson's work helped to establish the true, finite, and constant speed of light. Through these experiments, humanity discovered something profound. Light has a speed. It is unimaginably fast, but not infinite. This realization changed physics forever, because if light has a speed, then perhaps the universe has rules about motion, time, and space themselves. And this is exactly what Einstein would later uncover. At the beginning of the 20th century, a young physicist named Albert Einstein began thinking deeply about the nature of space, time, and motion. He asked a simple but radical question: what if the speed of light is not just fast, but the same for everyone, no matter how they move. Before Einstein, it was assumed that speeds should add up. If you are walking forward on a moving train, your speed is the sum of both. But Einstein realized that light doesn't behave this way. If you shine a beam of light on a train, whether the train is moving toward you, away from you, or standing still, the light always travels at the same speed, always the same. To make sense of this, Einstein proposed something extraordinary. It is not light that changes. It is space and time themselves. When you move faster, time for you slows down compared to someone at rest. This is called time dilation. Clocks tick more slowly. Your heartbeat, your thoughts, even your very life stretch out compared to others, and distances contract. At high speeds, the space in the direction you travel becomes shorter. Space itself adjusts so that light's speed never changes. It may sound strange, but experiments have proven it true again and again. Particles moving near the speed of light live longer than they should. Atomic clocks flown on airplanes tick differently than those on the ground. GPS satellites orbiting Earth must correct for relativity every second, or our navigation systems would fail. At the center of Einstein's theory lies a rule. Nothing with mass can ever reach the speed of light. Why? Because the faster an object moves, the more energy it requires to accelerate. And as it approaches the speed of light, that required energy grows without limit. To actually reach light speed would take infinite energy, and infinite energy is impossible. So light stands alone. Photons have no mass. They are born moving at the speed of light, and they always move at that speed. They cannot slow down, and they cannot go faster. This is why scientists sometimes call the speed of light the cosmic speed limit. It is the maximum pace at which information, matter, and cause and effect can travel. Imagine if light could go faster. Communication across the cosmos would change. Cause and effect might unravel. Time itself could lose meaning. But the universe does not allow this. The limit is firm, steady, and absolute. The constancy of light's speed is written into equations, woven into physics itself. It defines the very structure of reality. In a way, it is comforting. Amid the vastness of space and the chaos of stars being born and dying, there is at least one rule that never changes. Light will always travel at this exact speed, everywhere, always. And so, the speed of light becomes not just a number, but a foundation, a silent rhythm by which the cosmos keeps time. But there is a gentle twist to this story. Though the speed of light in a vacuum is absolute, light does not always travel through empty space. Often it passes through materials, air, water, glass, even diamond. And when it does, it slows down. This slowing is not because photons themselves move slower. In truth, between atoms, they still travel at the cosmic speed limit. But inside matter, light is absorbed and re-emitted by atoms, scattering and dancing in countless tiny interactions. These delays add up, and to us it appears as though light has slowed. In water, light moves about 25% slower than in a vacuum. In glass, it slows even more. And in diamond, one of the densest optical materials on Earth, light moves less than half its normal speed. This slowing explains why light bends when it passes from one medium to another, a phenomenon called refraction. It's why a straw looks bent in a glass of water, why prisms scatter light into rainbows, why the sparkle of a diamond seems so alive. Yet no matter how much light slows inside materials, the moment it leaves and re-enters empty space, it instantly resumes its full, natural pace. Always, it returns to the constant of 299,792,458 meters per second. Even in exotic experiments where scientists have managed to slow light almost to a standstill using clouds of ultra-cold atoms, this is not the true speed of photons changing. It is an illusion, a delay created by complex interactions. In the vacuum of space, light itself is always faithful to its limit. This delicate dance, slowing, bending, scattering, shapes our world. It gives us rainbows, sunsets painted in gold and red, and the shimmering beauty of stained glass windows. So while the speed of light is constant in the emptiness of space, its journey through matter creates much of the color and wonder that fills our eyes. Now we come to a question that often stirs the imagination. If the speed of light is the limit, can anything ever go faster? The answer is both simple and subtle. No object, no particle carrying information can move faster than light through space. That rule is solid. But the universe has its tricks. The cosmos itself is expanding, space is stretching, and distant galaxies are carried away from us by this expansion. The farther away they are, the faster they recede. At great enough distances, they seem to be moving away faster than light. Yet this does not break relativity. It is not the galaxies themselves moving through space. It is space itself growing, carrying them along. In this way, the observable universe is finite. Beyond a certain distance, the light from galaxies can never reach us, because the space between us expands too quickly. They slip forever beyond our view, hidden by the very speed limit that defines reality. Some scientists imagine possibilities of warp drives, bending space itself to move faster than light without violating relativity. These remain theories, beautiful but unproven. Others think about quantum entanglement, where particles seem to influence each other instantly, no matter the distance. But entanglement cannot transmit usable information faster than light. The speed limit still holds, so the universe gives us glimpses of things that look faster. But in truth, nothing carries information beyond the limit. Light remains the fastest messenger allowed. In the quiet truth of physics, the speed of light is not just a rule, it is a boundary and a promise. Perhaps the most enchanting consequence of light's speed is how it turns our gaze into a time machine. When you look at the moon, you see it not as it is now, but as it was a little more than 1 second ago. That is how long the light took to cross the gap. When you look at the sun, you are seeing it as it was 8 minutes in the past. If the sun vanished this instant, we would still see its light for 8 minutes more. Look farther and the delays grow longer. The light of distant stars has been traveling for years, centuries, or millennia. The starlight that twinkles above you tonight may have begun its journey before humans built the pyramids. Beyond our galaxy, light from Andromeda takes more than 2 million years to arrive. You are seeing it as it was before humans existed at all. And far beyond that, the light from distant galaxies has been traveling for billions of years. When astronomers peer into the deepest parts of the cosmos, they are not just seeing far away, they are seeing far back. At the very edge of visibility lies the cosmic microwave background, the afterglow of the Big Bang itself. It has been traveling to us for nearly 14 billion years. When we detect it, we are seeing the faint echo of the universe's very beginning, all because light has a finite speed. So each time you look into the night sky, you are not seeing the universe as it is. You are seeing the universe as it was. The sky is a vast museum of ancient light, each star a story carried across time. And in that way, the speed of light gives us one of the greatest gifts of all: the ability to glimpse the history of the cosmos, written across the heavens. So now, let us pause and gently gather the pieces of this journey. We began by asking, what is light? And we found that it is both a wave and a particle, a ripple in fields, and a photon traveling across space. We learned that in the emptiness of space, it always moves at the same speed, about 300 million meters per second, the fastest possible speed. We wandered back in time to Romer, Fizeau, Foucault, and Michelson, who discovered that light does not move instantly, but instead has a finite, measurable speed. We explored Einstein's vision, relativity, where time slows, space contracts, and nothing with mass can ever reach the speed of light. We saw how light bends and slows in water, glass, and diamond, scattering and painting the world with color. We wondered about things beyond the limit: expansion, entanglement, and dreams of warp drives. Yet still, the speed of light stands firm. And finally, we looked to the stars, and we realized that because light takes time to arrive, every star is a memory. Every galaxy is a glimpse of the past, The night sky is history shining down upon us. All of this flowing from one simple truth, the speed of light. And now, as our journey comes to an end, let the story of light fade gently into the quiet of your thoughts. The universe is vast, its rules are steady, and its wonders are endless. Among them, light is both simple and profound, a constant traveler, a faithful messenger, a silent clock that measures time across eternity. As you rest, imagine drifting with a beam of light, gliding across space, passing by stars, nebulae, and galaxies, each glowing softly in the dark. Feel yourself moving effortlessly, unbound, serene. There is no hurry, no destination, only the calm flow of the cosmos carrying you onward. And as you drift, let sleep take you, gently, quietly, like light fading into the horizon. Good night, and sweet dreams beneath the endless stars.